The Panzerfaust seems like a dangerous weapon indeed. It's powerful enough to penetrate the armor of even a heavy tank. It's very small, it's very light enough to be carried by just one man, and that one man doesn't have to be particularly skilled in order to fire it. It's more of a point and shoot situation. And well, most important thing for Germany towards the end of the war, running out of resources, it was very, very cheap, very, very easy to mass produce. And well, it doesn't really matter if you lose a couple of 100,000 to the enemy here and there when you can crank them out by the millions. And perhaps because of this power and because of how common it was, there's quite a few myths associated with both its use and defense against it. And I'm going to talk about defense against this weapon in general and address some of these myths. But first, let's talk about, well, what is the Panzerfaust? Where did it come from? By 1942, most German man-portable weapons, such as the Panzerbuchse 39 and the Gewehr Panzergranate 61, they were no longer capable of destroying enemy tanks, particularly the T-34 and the KD-1, which plagued the Germans on the Eastern Front. As a result, most tactics developed for German infantry to fight tanks actually bordered on either suicidal or ridiculous, like climbing up on the back of the tank and using an axe to chop at the engine grills, or climbing up on the tank with a bucket of mud and splattering it over the observation devices. And well, they really needed a real weapon rather than these interesting workarounds. And so Dr. Langweiler from the Hassag company began working on a weapon to help the German infantry. Dr. Langweiler already had experience with recoilless rifles, and so it wasn't much of a stretch from that to design something that was conceptually similar to the Gewehr Panzergranate. It was a shaped charge warhead shot from this time a recoilless launcher, and well, it didn't have to be all that precise. All you needed to do was hit a tank-sized target at about the range of 30 meters. The first prototype left much to be desired, but nevertheless the army was interested, and so the weapon was developed into what later became the Faust patron. Faust meaning fist and patron meaning cartridge, so a fist cartridge. The Faust patron fired a 100 millimeter caliber projectile, which could penetrate more or less around 1 caliber worth of armor. Heat cartridges in the 1940s, the early 1940s, they were quite temperamental, and so the actual degree of penetration and whether or not the fuse would activate at all, well, it was anyone's guess, but this 100 millimeters would be enough to fight pretty much any tank that this weapon would face at the time. Now, naturally, the army wanted something even bigger, and so work began on a weapon that would be called the Panzerfaust, or armor fist. The Panzerfaust had a bigger warhead, 150 millimeters, and penetration increased proportionally. And of course, since the warhead was bigger, the launcher was bigger, but the range remained the same, about 30 meters. The very primitive peep sights that this weapon used really didn't allow you to shoot at anything much further away anyway. So interestingly enough, it was the word Faustpatron that stuck to this weapon on the Eastern Front. Pretty much in any Russian language source, when they're talking about German man-portable anti-tank rocket launchers, it's going to be called Faustpatron. And even the people who use them, they are called Faustniki. And so even as the Germans, because of course development didn't stop at the Panzerfaust 30, even as the Germans developed different and more powerful anti-tank weapons, they were just all collectively called Faustpatron, and this introduces some confusion, which perhaps led to some of the myths. So from the Panzerfaust 30, 30 being the effective range in meters, the Germans went on to the Panzerfaust 60. 60, again, stands for the effective range. Of course, the primitive sights limited this range somewhat, but this weapon could effectively be used to hit a tank at a range of about 60 meters, which greatly increased the lifespan of its operators. Similarly, the Panzerfaust 100, developed even later, had a maximum range of 100 meters. The most important advancement was not the maximum range, but rather the muzzle velocity, which was double that of the original Panzerfaust. And you actually had a chance of hitting a moving target as opposed to having to wait for the enemy tank to stop before you could fire. More advanced variants of the Panzerfaust were developed, but since they never made it into the hands of German troops, they are going to remain outside the scope of this video. So if that wasn't enough, the Germans actually started working on another man-portable anti-tank weapon. This was called the Panzerschreck, or the Tank Terror. It was actually vaguely based on the American bazooka, but used an 88mm rocket from the Pupchin anti-tank gun, which was, even though it was also a recoilless anti-tank gun firing rockets, it was not man-portable. It was actually closer to a literal artillery gun than something like the bazooka. The Germans rolled out all of these weapons very, very gradually. The Panzerschrecks, Faustpatron, and Panzerfaust were actually available at roughly around the same time, towards the fall of 1943. These weapons arrived on the front lines in numbers by 1944, and well, their impact at first was not significant. The Red Army did note that, hey, the enemy is using a new kind of anti-tank weapon, but the Germans still had quite large numbers of traditional anti-tank guns. Plus, the very limited range of the Panzerfaust did not really allow it to be used on wide open territory. However, the British, who encountered the Germans in much closer quarters, both in Italy and in Normandy, where the Panzerfaust could be hiding behind the bocage, the British reported these weapons as a little bit more significant. 10% of tanks fell to enemy Panzerfausts, which isn't the majority, but it's also not nothing. The casualties from these kinds of weapons actually went up to 25%, and during pursuit operations, when the Germans couldn't deploy traditional anti-tank artillery, the percentage of losses from Panzerfaust could actually go up to 35%. But on the Eastern Front, the percentage was something around like 0.5% or 1%. Really almost nothing. Most of the tanks were still being lost to enemy artillery. The British stated that their tanks were being hit from ranges anywhere between 10 yards and 100 yards, but effectiveness greatly dropped at ranges of over 40 yards. Now, 40 yards is about 35-ish meters, so most likely the Germans were still using majority Panzerfaust 30s or Faust patrons, which could only be used at a shorter range. Meanwhile, on the Eastern Front, things were very, very different, even as late as 1945. In February of 1945, the Second Ukrainian Front reported that a total of 0.5% of its tanks fell victim to Panzerfausts. And remember, this combines all man-portable anti-tank rockets that the Germans were using. This was certainly not because the Germans weren't issuing these weapons, as the Red Army was capturing hundreds and thousands of these things. It was rather because the German infantry did not have the necessary morale to use such a close-range weapon. Frontline reports were coming in that enemy infantry usually breaks and runs within 200 to 300 meters of Soviet tanks, and, well, if you'll have a weapon with a maximum range of 30-ish meters, that's not really going to do you a lot of good. Even with Germany's surrender nearing, the percentage of losses from Panzerfaust was still not very high. The 9th Tank Corps reported just 9 hits, mind you, not kills, hits from Panzerfaust among all of its casualties during the Vistula-Oder offensive. And likewise, Chuykov's 8th Guards Army reported just 7 tank losses out of 122 attributed to Panzerfausts as they were seizing a foothold across the Oder. During the approach to Berlin, the ratio finally started catching up to what you could see on the Western Front. The same 2nd Guards Tank Army reported that 34% of hits on its tanks could be attributed to Panzerfausts, while 60% were still attributed to traditional anti-tank artillery, as their forces were nearing Berlin in April of 1945. However, inside the city, the ratio was actually reversed. 71% of hits scored on tanks were attributed to Panzerfausts, while only 27% came from traditional anti-tank guns. This is in no small part due to the fact that the Germans had fewer weapons of other types that they could deploy. It is quite interesting to note that the figure given by the Soviets, 34%, is almost exactly the same as the figure given on the Western Front, 35%. So the numbers eventually caught up as the Germans were forced to rely more and more on Panzerfausts due to losses of traditional anti-tank artillery. The Panzerfaust was most effective in built-up areas where the Germans could attack from short range, but outside of the city, artillery was still king and responsible for most of the anti-tank kills. Interestingly enough, the Panzerfaust was much less likely to destroy a tank outright. On the Western Front, 29% of tanks hit by hollow charge rockets were completely destroyed and couldn't be repaired, compared to 49% for traditional anti-tank guns. Unfortunately, I don't have data on the Eastern Front to compare, but there's a very resilient myth that the Panzerfaust was guaranteed to hit some ammunition in the tank and blow it up completely, but as these numbers demonstrate, that is very much not true. So the Panzerfaust, when used correctly in favorable conditions, was actually quite a powerful weapon. And so it's not surprising that frontline tankers decided to protect themselves against it, usually by putting something in front of the warhead in order to scatter the penetrating jet and dissipate it before it hits the main armor. I'm going to start with solutions developed on the Western Front, since the casualties on the Western Front were higher earlier, and so there was much more of an impetus to develop a countermeasure. The first mention of such a countermeasure I could actually find came from a Canadian intelligence summary in Italy. A Canadian intelligence officer who visited a number of tank units observed that there was a method of protection developed composed of a 5mm mild steel sheet with a bunch of sandbags behind it. The sheet was placed 12 inches away from the main tank armor, and this kind of method was actually quite effective against Panzerfausts. Just the 5mm thick sheet of metal, however, was not effective without the sandbags behind it. Unfortunately, just the sandbags alone were not tried. This goes to show that the Schützen armor plate, the spaced armor used on German tanks, was not an effective defense against Panzerfausts, and of course was not developed with that in mind. This is another very resilient myth. The Schützen plates are designed to protect against Soviet anti-tank rifles rather than hollow charge warheads. The Canadians did try quite a lot of other means of protecting against Panzerfausts. Covering your tank in track links, as seen in really many parts of the European theater, was not an effective defense. The only time during the trials when the Panzerfaust failed to penetrate was when it hit the guide horn rather than the face of the track. If it hit the track honestly, then even though the diameter of the penetration was reduced, our main armor was still penetrated. Canisters full of water were also tried as a sort of a blade of armor, and just as with the track links, the diameter was less, but the armor was still penetrated by the warhead. There were other interesting methods, such as tightly packed blankets that were designed to give the Panzerfaust a bit of a cushioning so that the fuse wouldn't go off, but none of these appeared to work at all. There was a bit of a more interesting method. A 7mm thick steel plate was installed at an angle of 45 degrees. When a Panzerfaust was fired at it, the warhead actually bounced off without fusing properly. Unfortunately, this was the last Panzerfaust that the testers had on hand, and they couldn't figure out whether or not it was a fluke or this was an effective method of protection. Armor layouts implementing this method, so steel plates installed at an angle, were developed. They were developed with the width restrictions of a Bailey bridge in mind, but I've never seen this kind of protection rolled out in production. So perhaps it was not as effective as it appeared from these trials. There was another trial concluded on October 6, 1944. Rather than use a steel plate, these trials used a steel mesh. The idea was the same. The warhead would blow up far away from the main armor, and that the standoff would result in decreased penetration. This solution was found to be quite effective against the Panzerfaust 30, but it was not effective against the Panzerfaust 60, which had warheads with a higher muzzle velocity. Nevertheless, protecting against the Panzerfaust 30 was better than nothing, and this could be an effective protection against German anti-tank weapons. Unfortunately, the standoff for this mesh had to be quite large, and it was impractical to drive around on complex Italian terrain with this kind of mesh sticking out. There was a folding mesh designed, which would fold up automatically when it hit some kind of obstruction, but work ended in April of 1945 when it was clear that the war is almost over and, well, there really isn't any point in continuing this work. Meanwhile, crews used whatever improvised protection they could find. Logs, sandbags, salvaged Schutzen plates, but the actual effectiveness of these methods of protection was not looked into, and the intelligence summaries wrote that it's most likely the greatest impact from this kind of protection is for the crew's own morale rather than any improvement to the tank's armor. Now, it wasn't just amateurs who decided to protect their tanks from Panzerfaust. Actual armor experts also took a swing at it. A bunch of experiments were conducted at the artillery proving grounds at Schuberines in the United Kingdom, where they found that an air gap 3 to 4 times of the projectile caliber actually offered some protection. The effectiveness of the stream was reduced to the point where it did not penetrate the armor of a Churchill tank. For example, a 6 mm thick steel plate placed 28 centimeters away from 3 inches of armor was found to be adequate protection from the Panzerfaust 30. However, the Panzerfaust 60 could still punch straight through this shield. There were a bunch of other non-metallic protections tried, like sand, wet sand, different kinds of ground-up metal shavings, but really none of them offered protection that was better pound for pound than just mild steel. The Americans developed a kind of plastic block armor that could be placed in front of the main armor and replaced as it was damaged, which did turn out to be effective, but as with the folding mesh armor, the war was pretty much over and there really was no point in continuing this design further. As you can see, despite this popular belief that standoffs actually made the Panzerfaust more powerful, it really depends on what kind of Panzerfaust you were facing. If it was a lower muzzle velocity type weapon, then solutions like meshes or standoff armor or sandbags did actually protect your tank somewhat, and you could survive, theoretically at least, a German ambush if you had this kind of extra armor on your tank. Now, let's go back to the Eastern Front. Remember the Sherman tank that I just showed you? Well, you could actually see something very similar in the USSR in 1943. That is because the Soviets were plagued by German shaped charge warheads long before the Panzerfaust came out. In 1942, the Panzer IV and its short 75mm gun, which were normally ineffective against the T-34 and KV, received a new type of ammunition. Hollow charge ammunition could penetrate at least the side armor of a T-34, and so development began for various protective techniques. Engineer Major Nikolai Fedorovich Tsiganov, who you may know from various strange pre-war projects, including the BTSV, had his own idea of how to protect the Soviet tanks. The idea was kind of similar to what the Americans came up with 3 years later. Non-metallic block placed in front of the main armor, which could take a hit from this incoming warhead. And once the block itself was destroyed by repeated impacts, you could simply take it off and replace it with a new one. Unfortunately for Tsiganov's solution, the material he had on hand was not plastic, but concrete. And the total armored package weighed about 10 tons, with each individual block weighing between 330 and 770 kilograms. This meant that you need some kind of crane to lift up these blocks and install them. Only 2 prototypes were built with Tsiganov's experimental armor. Because of its bulky size and weight, it was not considered to be a very practical solution. However, this was not Tsiganov's last attempt at improving the protection of T-34 tanks. Even though the Panzerfaust was not very common on the Eastern Front in 1944, he still analyzed tanks that were knocked out by this weapon and determined a countermeasure for them. It was very similar to what the British ended up with, being a mesh with a standoff. Unfortunately, Tsiganov himself was killed in battle before this solution was ever rolled out, but you've probably seen it in photos quite a few times. This solution was used in 1945 during the Battle of Berlin. For some reason, this kind of armor is often called bed spring armor or mattress armor, and I've even seen some versions of the myth claiming that the Red Army just piled mattresses on their tanks to protect them against Panzerfausts, but as you can see, that's really not the case here. This is a purpose-made metal grates, metal mesh rather, designed to protect against Panzerfausts, specifically designed for this purpose based on Signal's protection research. And again, despite the claim that a standoff only makes a Panzerfaust more powerful, Soviet documents state that this kind of protection was very effective. Now, they just say Panzerfaust, Faustpatron rather. They don't say what kind was encountered, so it is very possible that same as the armor the British and the Americans developed, it was only effective against the older and smaller types as opposed to the later and larger warheads with higher muzzle velocities. But nevertheless, it still proved itself to be effective in combat. Now, documents covering the Berlin offensive operation do mention another very effective countermeasure to the Panzerfaust: infantry. Soviet tank riders, by 1945, very well equipped with automatic weapons, could simply shoot at any suspicious-looking bush or other concealment where a Faust tank could be hiding. And that usually had a pretty good effect of either suppressing them or flushing them out before the tank close to a range where the Panzerfaust could be fired. Turns out the best way to avoid being destroyed by a Panzerfaust is to not allow your enemy to fire it at all. To conclude, the Panzerfaust, even though it was a very powerful weapon and available in large numbers, was considerably hampered by its short range. It could only effectively be used in densely built-up areas or other spaces where traditional anti-tank weapons could not be employed. Many crews and many professionals decided to seek out a method of protection. And by the end of the war, even though protection against smaller and weaker kind of Panzerfaust was developed, no method was found that was entirely effective against all of them. It turned out that the most effective way to protect your tank is to just surround it with an infantry escort and prevent the enemy from firing their weapon at all.